Hi, my name is Daniela Lopez. I'm in calculus class, third hour, and this is my presentation of the chapter 2 of related rates. So this is our problem. A cone-shaped tank is leaking water at a constant rate of 5 inches cubed per hour. The radius of the tank is 10 inches and the height is 16 inches. At what rate is the depth of the water changing when the depth of the water is 8 inches? Since we're talking about a cone, we're going to start by drawing 3 different triangles that we're going to use to label our variables. So as I say, on the first one we're going to use it for variables, the second one we're going to use it for full tank, and the third one we're going to use it for water. So we're going to start by calling this h, which is going to be our height, and then we're going to start by calling this part r, which is going to serve for radius, because we know that the whole bottom part will be the base, but which is going to be the diameter, but they're giving us a radius, so that's going to be half of it. And then from the information that they give us, we know that the height of the full tank is 16 inches, and we also know that the radius is 10. They also tell us that the rate is the depth of the water is changing when the depth of the water is 8 inches. So we know that in this case the height is going to be 8 inches. And now we can infer that 16 divided by 2 is going to be 8. So to get our last variable that we are missing, we can tell that 10 divided by 2 is going to be 5. So now we have to set up an equation so that we can solve this problem. And since we're talking about the depth of the water, we know that we're going to be talking about volume. And we also know that the formula for the volume of a cone is volume equal 1/3 pi times r squared times h. So we're going to start by taking the derivative of this equation. So b is going to become b prime. Then we're just going to copy that 1/3 pi. And then we're going to apply quotient rule because we have that r squared. So we're going to drop the 2 down. We're going to copy the r, and then we're going to lower the power. So it's just going to stay as r because it's r to the 1 power. Then we take the derivative, which is going to be r prime, and then we keep the rest, which is going to be h, plus keep the first times derivative of the second. So keep the first is going to be r squared, and the derivative of the second is going to become h prime. So now that we have our derivative of the function, we know what are going to be the variables that we're going to be needing to solve this problem. So we know that we're going to need b prime, we're going to need r, we're also going to need r prime, we're going to need h, and we're also going to need h prime. So from the information that we have on the drawings that we did, we know that b prime is going to be equal to -5. So here it says that the tank is leaking water at a constant rate of 5 inches cubed per hour. Since we're saying it's inches cubed, we know that we're talking about volume, and in this case is -5 because we know that the water is leaking. So then from our drawings, we know that the radius, which is r, is going to be equal to 5, and then we know that h is going to be equal to 8, and h prime is what we're trying to solve for. So now we just need to find r prime. So here we know that we have some similar triangles because we saw here that how 16 divided by 2 is going to be 8. So we need to set up an equation so that we can find what is r prime equal to. So we're going to set our equation, which in this case is going to be r over h is equal to 10 over 16. We're going to cross multiply, so we're going to end up getting 16r equals 10h, and then we're going to simplify this a little bit. So we're going to end up getting 8r equals 5h because we divide both sides by 2. Now we have to take the derivative, so we're going to end up getting 8r prime equals 5h prime. So now we're going to try to get r prime by itself. So r prime equals 5 over 8h prime. So now that we have all of our variables, what we're going to do next is we're going to substitute in our equation. So we're going to start by b prime, which is -5. We got the 1/3 pi, and then we'll have 2 times r, which is 5, times r prime, which is 5 over 8h prime, plus r squared, which is going to be 5 squared, times h prime. So to get rid of 1/3 of pi, we're going to multiply both sides by that, so we're going to end up getting negative 15 over pi. And then on the inside, we're going to get 2 times 5 over 8h prime is going to give us 50h prime, plus 5 squared, which is going to be 25, and then we just copy the h prime. So now we're going to try to simplify this a little bit, so we're going to end up getting that negative 15 over pi is equal to 75h prime. So now we have to try to get h prime by itself. So we're going to have to divide both sides by 75. So we're going to get h prime is equal to 1 over 5 pi. So our final answer for this problem will be that the depth of the water is changing at a rate of 1 over 5 pi inches per hour